Consider the function f of x equals x squared e to the 18x. Determine the intervals where this function is increasing or decreasing. Alright, so in order to determine where a function is increasing or decreasing, we rely on these two principles. So whenever the first derivative is greater than 0, that tells me that the function itself is increasing. And whenever the first derivative is less than 0, that tells me that the function is decreasing. In order to do any of these tests, I need to have the derivative, so let's begin there. So the derivative of this function, notice I have two pieces of functions that are multiplied together, which means I need the product rule. So that says to take the derivative of the first times the second plus the first times the derivative of the second, which would be 18 e to the 18x. Normally, you're not required to simplify derivatives, but if you're going to work with a derivative in any way, it's best to have the simplest function you possibly can. So let's factor out x e to the 18x. So that would leave me in this first term. If I'm pulling out e to the 18x and x, the only thing left there is just a 2. All right, in the second term, if I'm taking out e to the 18x and an x, then that would leave me 18x. All right, and in fact, I actually could have pulled out another factor of 2. So let me go ahead and do that. So 2x e to the 18x times, and I'll make this 9x plus 1. All right, so that's probably the simplest form that we're going to get. Now, I want to know where this function is increasing or decreasing. So I need to know where it is bigger than 0 and where it is smaller than 0. In order to determine that, I first need to figure out where it's equal to 0. That's the simplest way to do this. So I set this derivative equal to 0. And effectively, I am looking for critical values. Now, critical values can occur whenever your derivative is 0 or undefined. But there's no points that would give me division by 0 or anything of that nature. So I don't have any undefined values, it looks like. All right, so right now I have effectively 3 factors. And the product of these 3 factors is 0. And what that means is, in order to have 3 numbers that multiply together that result in 0, that means that the first number had to be 0, the second number had to be 0, or the third number had to be 0. One of those statements had to be true. So they're all possible, so we consider them all as potential places where solutions exist. If I solve the first one, I get x equals 0 as a critical value. The second one, notice that this is an exponential with base e. If I tried to change this into a logarithm, and the reason I would do that is because there is an exponent in the argument, or there's a variable in the exponent is what I tried to say. And whenever there's a variable in the exponent of an exponential, you switch it to a logarithm to solve. All right, so doing that, it would be a log base e, which is a natural logarithm, of this number over here equal to 18x. But we can't take the logarithm of 0. That's an undefined value. That's where the asymptote is in a logarithmic equation. So that right there doesn't give us any solutions. It doesn't mess up our problem, it just doesn't give us any solutions. All right, so then, and actually another way to think about that is when you have an exponential functions approach 0, but they never actually equal 0. You have a horizontal asymptote at 0. So that's another way to think about it if you want to save some time. All right, solving the last one, since that is linear, I could write 9x equals -1, or x equals -1 1/9. So that gives me two critical values here. So I'll put these critical values on a number line and make sure they are in order. So -1/9 and 0. What I need to do is determine which intervals I am increasing and which intervals I'm decreasing just by choosing some test values within each interval. So the test value here that I'll use is -1. That's a simple one. Within here, that's a bit tricky because -1/9 is pretty close to 0. But I could use something, I suppose, like -1/10. I believe that would do what I want. Let's see. 1/9 is 0.1111. All right, and just to show you, 1/10 is smaller than that, which means it's closer to 0. So if I had chosen like 1/100, for instance, that would be fine as well. Whoops. That would give me a value that is between 0 and -1/9. So -1/10 will work fine. All right, and on this end, I think I'm going to go with an easy value of just +1. All right, now to determine if I'm increasing or decreasing on these intervals, I need to plug each of these values into the derivative. So f prime evaluated at -1, f prime evaluated at -1/10, and f prime evaluated at 1. Now, this might not actually be too bad analytically, but because there's a few different terms here, I think what I'm going to do is just plug this into the calculator. So 2x, then e raised to the 18x, and that's multiplied by 9x plus 1. Oh, why do I have a pi there? Oops. Oh, I think I hit second and the caret key instead of just the caret key. All right, so there's my function. Now I'm going to use a table. Let me just make sure my table is set up properly. And I will input these values given here. So -1, -1/10, and +1. All right, so at -1, I get positive 2.4 e to the -7th power. It's not a very large number, but it is positive. So we are increasing on that interval. So positive there, so we are increasing. And then it's negative on the next interval. So that means we are decreasing. And then the first derivative is positive on this last interval, which means we're again increasing here. So to give the intervals where this function is increasing or decreasing, I guess what I'll say here is just f is increasing on the intervals from -infinity to -1/9, and then again from 0 to +infinity. And f is decreasing on the interval from -1/9 over to 0. And that takes care of where this function's increasing and decreasing.